All right, we have come to the end. This is our last lesson, and it's two-step equations. Two-step equations with the do-undo method. This is why I taught you guys, or wanted you to understand the do-undo method for one-step equations, because we're going to use it in this method. We're again looking at SADMAP. The reason we do that is because if I were evaluating or plugging in a number, I'd be using PEMDAS. So I'm going to stress the SADMAP part. Again, first look at the problem, see if it needs to be rewritten. Is it in proper order? Is the variable first? If it is, rewrite. If it isn't, rewrite it. Then you're going to read it, stressing the math words, the multiply, the divide, the add, subtract, the parentheses, whatever. We're going to write down our do. What does it say to do when I read it? And then we're going to do the undo. And this is a little bit different. The undo has to be done in SADMAP form. We're going to solve it and we're going to check it. So this one says a divided by 4, something divided by 4, plus 2 is 6. Notice I did evaluation method. I'm going to multiply and divide, and then I'm going to add and subtract. Well, since I don't know what this number is, I can't do that. So I'm going to go back to SADMAP. SADMAP says if I'm going to solve this equation, I have to add or subtract first. So when I get to this undo, I have to start here. The opposite of add 2 is subtract 2. And then the opposite of divide 4 is times 4. And what I'm going to undo is the constant term over here, 6. So 6 subtract 2, or 6 minus 2 is 4. 4 times 4 is 16. I've solved it, yay! But I got to check it. Make sure you did the math correctly. It doesn't make sense. 16 divided by 4 is 4. 4 plus 2 is 6. Yep, it worked. This is where I really want to stress the fact of what PEMDAS says so that you can undo it with SADMAP. If I were dealing with this one in PEMDAS, I would deal with the parentheses first. So I would plug in a number and I would add 5 to it. Once I have that number, I would multiply by 2. I'm not going to distribute the 2 through here. Distribution is not part of PEMDAS in this case. I'm really just looking at what's going on. I saw parentheses. What am I doing in the parentheses? That overrides the multiply and divide that distributive property does. So anyway, it says 2 times whatever's in that parentheses. Now when I work through SADMAP, this is the important part. The parentheses are at the end. So if I am solving this, I'm leaving those parentheses alone. And again, I'm starting with this operation here, and I'm writing its undo first. It doesn't matter if you don't distribute. When you do that division, you will get the right answer. Even if it comes out to be a fraction or a decimal first, it'll be fine. If you had distributed and solved this that way, you're still going to get a fraction or a decimal. So divide by 2 and then subtract 5. I'm going to start with the negative 4, the constant. So negative 4 divided by 2 is negative 2. Only one negative sign and negative sign in my answer. Negative 2 minus 5 is negative 7. They're both negative, so I add them together and put a negative sign on it. Now this is where I'm going to check it. 2 times negative 7 plus 5 equals negative 4. Negative 7 plus 5 is negative 2. 2 times a negative 2 is negative 4. Hooray, I did it correctly. I'm going to scroll down here so that I can show you the next. The 2 problems before, we had some division, we had some multiplication. We have some addition, and we have some subtraction. That's it. That's a 2-step equation. They all have the same processes in there. They don't always have division and addition or multiplication and subtraction. It just depends. All right, so this one first is written backwards. So I'm going to think about it a different way. Something divided by 4 minus 6. Notice I changed this negative into, say, subtract or minus. And it's going to equal a negative 5. I'm going to put that variable first. Again, there's a reason when I do this do, undo. Something divided by 4 minus 6 is negative 5. I'm going to undo from the negative 5, add 6, and then times 4. There's no reason these numbers are exactly the same as the first problem. I just left it that way. So negative 5 plus 6 is 1. 1 times 4 is 4. Now I can check it. 4 divided by 4 is 1. 1 minus 6 is negative 5. It works. Here's a multiplication and a subtraction. I don't have parentheses on this one, so I'm going to do it exactly the way it reads with PEMDAS. 9 times something, subtract 7, gives me negative 20. So I'm undoing the negative 20. First working with the subtraction because now I'm working SADMEP. That's the S in SADMEP. So the opposite of S is A. Add 7. And the opposite of the multiplication is division. Divide by 9. So I'm going to have negative 20 plus 7 is negative 13. Negative 13 divided by 9 is a fraction. This becomes a little bit trickier when I go to check it, unless I remember my fraction rules, and hopefully you guys remember how we did these before. I'm using the parentheses instead. So 9 times a negative 13 ninths, these factor out. So it says negative 13 minus 7 is negative 20. 13 plus 7 is 20. They're both negative, so yep, it still checks. All right, let's look at a couple more just because we can, and just to make sure you guys are understanding what's going on. And just because I have one more that's a little bit different with a special case in here too when I rewrite it. So this one says 7 times 9 plus A. If I were going to do this with PEMDAS, remember I'm going to evaluate what's in here first. But it's also written a little bit incorrectly. So we're going to say 7 times something plus 9 equals 84. So I would add 9 to that something because it's in the parentheses, and then I would multiply it by 7. I'm going to undo that 84. Starting down here again, I'm going to divide by 7, and then I'm going to subtract 9. So 84 divided by 7 is 12. Grab a calculator if you need to. 12 minus 9 is 3. Now let's go back and check it. If I put a 3 in here, 9 plus 3 is 12. Notice I'm doing the do. 7 times 12 is 84. It checks. All right, everyone's all kinds of different things going on it, so it's a kind of a special case. If I were to look at this, first I'd rewrite that numerator as negative x plus 5. Negative goes with the x, 5 is added. Divided by negative 6 equals negative 1. So first off, there's no such thing as a negative variable, and I don't want to have to deal with that. So what I'm going to do is I'm going to change the problem into x minus 5. I'm going to switch that negative here. And I'm also going to take it out of the bottom. Normally I would just multiply or move that negative to the bottom, so that's what I'm doing here. And I promise this works. So it says something minus 5. It acts like that numerator is in parentheses. So something minus 5 divided by 6 is 1. When I undo this, this fraction part says I have to deal with the denominator. So I'm going to multiply by 6. And then I'm going to add 5. So I'm going to take the negative 1. I'm going to multiply it by a negative 6, or a positive 6, sorry, and get negative 6. Negative 6 plus 5 is negative 1. I'm going to go back to the beginning and check it. 5 minus a negative 1 divided by a negative 6. So this says 5 plus 1 is 6. 6 divided by a negative 6 is negative 1, and it checks. All right. Hopefully you guys can catch on to solving two-step equations. I apologize that this video was kind of long, but there's a lot involved to understand two-step equations.